Yeah, good afternoon, one and all. So today we are going to see about the importance of power system planning, operational analysis. Okay, so why the planning is necessary? So what is the importance of operational analysis? Okay, so if you see the power system planning, it covers the maintenance of generation, transmission, and distribution facilities. Say, for example, if you are going for planning for a long term, if you're going for the planning, if you're going to plan for a long term, yeah. If you're going to plan for a long term, so that will be useful for say for example, if you are planning a substation, okay, if you are planning a substation for some long term, some 10 years after. So 10 years after, we could not able to know, okay, our okay, the load will be this much only. Say for example, now the load is in a particular substation, it is 0.5 megawatt. In 10 years after, it might be double the times or triple the times also, because due to ever increasing the population, and also due to the industrial revolution, and day by day we are adding the new loads to our homes. Say for example, we are upgrading a new okay, refrigerators, washing machine. Say for example, instead of 200-liter washing machine, sorry, 200 liters refrigerator, you are buying 500 liters. Okay, you are upgrading for the more. And if you take the ACs, instead of 1 ton ACs, what we are doing? Okay, we are going for 1.10 AC, 210 AC. So load is being increased like anything. Okay, so load is it is like if the load is say for example 5 kilowatt. Okay, so after after some months, it might be of 10 kilowatts. So like that, the load might be increasing like anything. So planning is very important, because in future, if we don't know how the load may be, so planning so implementation of plans, so implementation of plans will take some more time. Okay, say for example, if you are planning a power system, so definitely it will take some years. Okay, some 2 years for the completion of whole thing. Okay, so because transmission line need to be you say for example, in the particular line, the distribution system, you need to do more poles, then transformers will need to be added. Next, it will take more time, the planning and operation. So on the operation, slowly, if the based on the loads, you can increase the your feeders, you can increase the particular lines. Okay, so length of the line you can increase, and the width of the line, wires, you can increase. So because to withstand that particular current into that particular thing, so that there you have to go for more possible transmission lines. Next, the distribution system. Distribution system also like a more distribution transformers. Distribution transformers we need to add in the line. Okay, so then only the losses you can minimize at the distribution system. If you are minimizing the loss in the distribution system, thereby you are improving the system efficiency in the substation. So that way, the stability of the system will be maintained. So many things are there. Okay, that will come to the later. Next, monitoring. So monitoring and comparing the plans with the results. Okay, so for that, so planning is needed. Next, implementation of planning. Next is monitoring. So monitoring with the results. Say for example, you are simulating approximately this is the generating station, we need to add more, this is the substation size, this is the load. So what happens in the system? So if the fault happens, how to rectify it? Like that, many we are taking for monitoring and comparing the plants with the results. Everything we are doing, and then only we are going for the extension, future extension. So correspondingly corrective actions has to be taken. Say for example, any flaws in the particular equipment, say for example transformer is not withstanding that particular load, so some corrective actions to be needed. So again, that corrective actions we are sending to planning. Okay, so based on that, we are planning the system mode, and also some undesirable condition may comes. Okay, some faults, some major faults may happen. So how to plan for that faults? So that also we need to do it in prior. Then you have to go for the extension of the system. Okay, so this is the block diagram for planning and operation of the power system. So what are the steps to be followed? So what are the steps to be followed? First, you need to plan the power system. Next, implementation of plans. Next, to monitoring the system. Monitoring the system. So comparing the results. Comparing the results, as I said, say for example, faults happening in the system. So based on this faults, how to rectify that faults, line to ground faults, double line to ground faults, any sudden transient happens in the system, okay, due to lightning. Okay, so for this many few seconds, so how to withstand that fault? So okay, so what are the protective devices we need to install in the distribution system? So like that, many things are there. Not only distribution system, so throughout the power system. Okay, so next, if no undesirable deviation occurs, then directly you go to the planning the systems. Okay, so we are planning for that. If no no not much deviation, then you can directly go for planning. If deviation is there, so again you need to go for the corrective action to increase the system or decrease the system, or further to plan the system. Like that, some corrective actions are needed in the power system. These are the steps to be followed for the planning and operation of the power system. Okay, so for planning and operation of the power system, the following analysis, important analysis are to be made. The first one is load flow analysis. Next is short circuit analysis. Next is transient analysis. So these are there are many analyses are there. So these are the some of the major analysis that we are going to do in the power system. Okay, if you done with all these things, then almost you can go for planning your system. Okay, this is the major analysis. So first is load flow analysis. As the name itself, load flow analysis. Okay, so normally in electric power system operate in their steady state, always steady state mode. So and the basic calculation required to determine the characteristics of the state is called load flow. Okay, so normally in the steady state mode, we are operating our power system. So based on the power system, we already made some basic calculations. Okay, so this much generator is required for maintaining this much load. Okay, so approximately from the load generating station to load centers. So what might be the distance? So that what might be the losses? Okay, how the because distance is there, this much distance is there, approximately some 200 kilometers, 300 kilometer distance is there. So what might be the losses? How to reduce that losses? Okay, any switching substation we need to add in between. So like that, that also we are going to plan. So basic calculation required to determine the characteristics of the states is called load flow. Okay. Next, power flow studies are used to determine the voltage, current, active and reactive power flow in the given power system. So while doing this power flow studies, what we are doing, we are calculating is we are determining the voltage, current, active power of the system, reactive power of the system. So what might be the active power, what might be the reactive power in the particular system? So that and all we are easily calculating. Okay, so based on the these results, so what might be the change in voltage? Say for example, voltage you are sending some 400 kilovolts. Okay, so 400 kilovolts you are sending. Okay, so in the kilovolts, this much power, say for example, 500 megawatt of power you are sending. Okay, say for example, at the receiving it, you are receiving only around some 1000. 500 and 1400 megawatt. So some 100 megawatt or 80 megawatt, so 1420 megawatt you are receiving. So due to that distance, might be the losses of this particular thing. So what might be the change in the voltage? Okay, what might be the change in the voltage? Say for example, it is crossing so many buses in between. Okay, so what might be the change in the voltage? What might be the change in the phase angle? What might be the change in the active power? What might be the change in the reactive power? So everything. What might be the change in the current? Okay, this many mega amperes you are setting. Okay, so in the receiving end you are getting somewhat 15 percentage lesser. Okay, so what is the change in the current? Everything we are analyzing in this power flow studies. Next is a number of operating conditions can be analyzed, including the contingencies such as loss of generator, loss of transmission line, and the loss of the transformer, etc. So what we are doing is, so we are analyzing the number of operating conditions. Sudden, say for example, sudden loss in the one generator. Say for example, 10 generators contributing a particular load. So if sudden faults is happening in the one generator, so only 9 generators are there. So what might be the impact on the load? Okay, how the load will change. So what might be the impact of, say for example, the generator size is reducing. Okay, the power from the all this generator also somewhat reducing to 500 megawatt. So what might be the load? So say for example, as I said, the losses in the transmission line. So losses is sometimes losses is more. So what might be the how to operate the how to manage that load? So sudden loss in the load. Say for example, you are planning for a particular area, you are planning for 1500 megawatt, but suddenly the climate is very dull, or okay, it is raining heavily. So in that case, sudden loss in the load. Okay, sudden loss in the load. So sudden loss, say for example, 1500 megawatt to 200 megawatt, suddenly it is getting dropped. Okay, for certain hours, for half an hour, more than that. Okay, so suddenly we need to give the intimation from the substation to the generating station, like a load is dropping, like that some intimation. So if it is sudden drop in the load, what might be the what we have to do in the generator. So everything we are analyzing, we are contingency analysis. Okay. Next is contingency analysis. Any sudden contingency is nothing but sudden loss in the load. Okay, sudden drop in the load, like that. So anything we are analyzing previously, and based on the condition we are managing the system. Okay, so for that, load flow studies or power flow studies is very important. So these conditions may cause the equipment overload sometimes, or unacceptable voltage levels. Okay, so voltage levels we need to increase like anything that time. So if you plan priorly, then these conditions you can avoid. Next, study results can be used to determine the optimum size and location of capacitor for the power factor. So power factor also plays a major role in the system. Okay, so what might be the power factor? So usually it should be 1, but practically if you take it will be somewhat less than 1. So 0.99 or 0.98 like that. But we need to maintain the power factor as 1. But 0.99 is good power factor. 0.99 is good power factor. If you are maintaining 0.99 for long term, sometimes 1 it will come, sometimes 0.99. So it depends on the load how we are utilizing. Okay, like if the industrial loads are very more sometimes, then automatically the power factor might be reduced. Okay, so what they will do, the power substation they will call to like large consumers like industries. They will ask them to off the particular machine or load for sometimes. Okay, then if the power factor is maintaining constant, because all are grid connected system, I'll come to that later. The grid. Okay, how the India, how it is connected with the grid. So how many grid centers are there and around India? So it is everything is connected in the grid. So if you are not maintaining the power factor in one substation, then your particular regional load dispatch center will affect them with the power factor. Power factor of that particular region will be less. So that is being connected to state load dispatch center. So state load dispatch center is being connected with the regional load dispatch center. So regional load dispatch center is connected to the national grid. Okay. So if we are not maintaining the power, one substation maintaining the power factor, so everywhere it will reflect. Okay. Everywhere it will reflect. That is state load dispatch center will affect and national load dispatch center will affect. The grid will affect. So many problems might arise. Okay, so result of this power flow analysis are starting point of the this stability analysis. So load flow study is done during the planning of new system and extension of the existing one. Okay, so if you are planning for the new system, then again you need to conduct the load flow study. Okay, and any extension also you need to do the same. Next, this is also needed to evaluate the effect of different loading condition of the existing system. Okay. So loading conditions also we can analyze by using this load flow studies. Next, coming to the next part, start circuit studies. So this also plays a major role in short circuit. Okay, short circuit. If sudden short, any short circuit is happening in the power system, so you need to give the uninterrupted power supply to all the contributors. So if any short circuit, any fault happens in the system, so again you can't give the uninterrupted power supply. Automatically, the circuit breaker will trip. Okay, circuit breaker will trip in the particular substation. That feeder will be getting tripping. Okay, so again you need to go to the particular place. So where the say for example line to ground fault or double line to ground fault. So whatever the fault might be. So we need to rectify that fault. Minimum it will take half an hour to 1 hour. Okay, so by the time that particular area will not get the power. Okay, so analyzing the short circuit is a very important factor. So short circuit of the any part of the power cause manifold increase in the current, sudden increase in the current. Okay, so sudden increase in the current happening in the in the previous olden days, 15-20 years back. So I think you might have also come across this. If you ask your parents or your relatives, there will be a sudden blowout through the televisions and all. Okay, so your picture tube will immediately will go due to the sudden increase in the current, and that time no protection, system protection is there, but not that much. Protection will be there, like nowadays. Okay, so nowadays protection is like any, but that time those time no protection might be there for a limited thing. Okay, so the current will be increasing like suddenly in the system. Okay, so no detection of the sudden increase in the current, no tripping anything. So your equipments will not easily failure. Like your the picture tube TV, television will be there, CRT TV. So that and all will easily get damaged. So nowadays, all our LED TVs and all DC supply. Okay, so working on the DC supply. So there will be not much, okay, because the rectifier unit will be there. Okay, rectifier unit will be there. So there will be not much impact. So even though impact is there, but there will be not much impact in the olden days. So short circuit study analysis makes a major role in this. Okay, so when abnormal condition comes, so automatically this studies will help us to determine the fault and what is the time taken to rectify that fault. That also will be calculated prior. So for us, it will be very easy. Depends on the distance. So how much distance? That also we are performing in anything. So we are ready with all the data, ready with everything. So if any fault happens, we can easily identify the fault and what are the corrective actions like that we can easily do, and then the power system will be stable. Okay, so these studies are performed to determine the magnitude of the current flowing throughout the power system and various time intervals after the fault. So after the fault, so how the magnitude of current is get increasing. So what they will do is they will simulate that model they will inject the fault. Okay, they will make the artificial fault in that, and that means they inject more current to that particular line. They will see what happens to the system. Okay, whether the circuit breaker is tripping or not. Like that, everything they will check. Okay, so for that, this short circuit studies are important for us. Next, the magnitude of the current flowing throughout the power system after the fault varies with the time until it reaches the steady state condition. Okay, so that also then. Next, the objective of this short circuit studies is precisely determine the current and voltage at the different location of the system. As I said, location of, say for example, from the substation to some say, 2 kilometer after one fault is happening. Okay, so say for example, line to ground fault is happening. So what might be the current increase? So what, say for example, line to line fault is happening, double line to ground fault is happening, so open conductor fault is happening. So like that, we are doing the many analysis. Okay, so that also we are precisely we can tell what is the current and voltage in that particular different location if the fault happens in that particular within 1 kilometer to 2 kilometer, within the 2 to 3 kilometer, 3 to 5 kilometer. Like that, we can easily analyze that what happens in the system. Like that. Okay, so this data is used to select the fuses. Okay, fuses, protective relays, okay, circuit breakers to rescue the system from the abnormal condition. And next is symmetrical component and sequence networks are also used in the analysis of unsymmetrical faults. Okay, so these faults will come later. Symmetrical, what is symmetrical fault? What is the sequence network? Okay, what is the unsymmetrical fault? That will come in later in detail. Okay, next analysis is transient stability analysis. So, what is transient stability analysis? The ability of the power system consisting of two or more generators to continue to operate after the change occurs on the system. Okay, is a measure of the stability that you know. Okay, so sudden transients happen in the system. How the system is system is accepting that transients. So how what are the changes occurring in the system? So what so that is called the and also the measure of the stability. Okay, so that is the transient stability analysis. So in the power system, the stability on the power flow stability depends on the power flow patterns, generator characteristics, system loading level. Okay, so what is the power flow patterns? So power flow patterns also they will record. Okay, so and the generator characteristics. Okay, so characteristics of that and the SIL, that is system loading level. Okay, system loading level and the line parameters. So everything we will analyze. So what are the forms of instability in the power system, such as loss of synchronism between the synchronous machine and stalling of okay, asynchronous load, etc. So this stability may be divided into steady state stability and transient stability. So what is meant by steady state stability? Steady state stability is defined as ability of the power system to remain in the synchronism following relatively slow load change or continual changes in the generation and switching out of the lines. Okay, so steady is the ability of the system to remain in the synchronism mode following relatively slow load change or continual change in the generation or switching on the system. Okay, next is transient stability. What is transient stability? Transient stability is defined as the ability of the power system to remain in synchronism under large disturbance conditions such as fault and switching operation. Okay, large disturbance conditions, sudden fault, okay, sudden transients from the system. Next, so sudden lightning in the system. Okay, so that how the system can able to withstand that stability. So that and all we are going studying detail. Next, the maximum power transfer limit is less than that of the steady state condition. Okay, so transient stability studies are conducted when a new generating and transmission facilities are planned. Okay, so when a new generating station and transmission systems are planned, then we need to conduct this transient stability studies. Okay, so these studies are helpful in determining the nature of the relaying system, okay, relay system, and the critical clearing time of the circuit breaker. Okay, so critical clearing time you already studied in your past protection. So that time you need to set in the circuit breakers. So that also, if you do this study, then automatically, approximately, you can identify what is the critical clearing time of the circuit breaker. That also we can know in prior. And the next, voltage level and transfer capability between the systems. Okay, so what might be the voltage level? What might be the transfer capability between this system? So etc. and all we can study by using this transient stability. Okay, so